All right, so for our next talk that we have up for you here, we've got Chris Doman, who's going to be talking a little bit more on cloud resource forensics. Certainly interesting porting knowledge of host-based artifacts and saying, how does that change when you come down to not necessarily the services like we saw with EKS, but talk about those from a resource level. So very glad to have you here. Welcome, and looking forward to your talk. Thank you.
Yeah, thanks. That's a much better summary of the talk than the mammoth agenda I wrote, if you saw that on the website. So thanks for coming to the talk in spite of that. So today's talk is on cloud forensics, particularly talking about some of the kind of resource level forensics and incident response, not just on the log analysis side. Just told this clicker works for every presentation. It's running on the same channel, so the next speaker can also go back and forth as well. So my name is Chris. Lovely to meet all of you. I'm the co-founder of a company named Kata Security, and we build a software platform that automates collecting forensic artifacts in clouds and various incident response things. So that's why I'm here, because in order to do that, we've had to do lots of testing, lots of writing code, lots of writing tests around collecting data, various different ways and processing it. So today, I'm going to talk about some of the lessons learned from far smarter people than me on the team. So yeah, like I said, this is the summary of the talk. Bit of log forensics, bit more kind of resource level forensics. About 50 slides, I think. I saw Ashton is drawing these lovely speaker deck notes, so I apologize if your hand's very tired by the end of it. We're kind of kicking off with it. Something I've seen a few people talk about and kind of asked the last few months is, in the cloud, can you complete your investigation, maybe find root cause, identify the materiality of the breach, just using kind of logs from the cloud providers themselves? Because often that is what people end up just having to work with. And the answer, of course, is it depends. Depends on what type of breach it is, what's been impacted, etc. This is said far more comically by Florian Roth. This is his tweet. Meme of DFIR are in the cloud. Behind the scenes is just log analysis. I think he meant a few different things by this. He kind of went into it a bit. One particular thing he was talking about was that often you're kind of stuck with dealing with whatever the cloud providers have deigned to give you. But there is definitely more data you can get. And often it's up to you as well as the user to enable that extra data in advance. The couple of definitions won't take long. Definitions are all that exciting. But by cloud forensics, you can mean a few different things. If you're talking about forensics of everything on your cloud estate, it's going to involve things like host forensics. So, your Windows forensics, Linux forensics, new course on Linux forensics, SANS, I hear. Could include things like network forensics too. So, you can do a mirror attack. You can get the kind of network level data as well in your cloud environment. Then also log analysis in a couple of different ways. So logs from applications, logs from the cloud provider, and such, so many different things. Although sometimes when we talk about cloud forensics, they really are talking very much about the cloud provider specific logs too. So, your uses may vary. Or a lazy way to do this is just take an existing definition of forensics, stick the word cloud in front of it, or at the end. This is the shortest definition of forensics I could find online. May not be the best, but basically cloud forensics is forensics in the cloud, right? I really like the way that AWS splits up incidents in the cloud into different domains. It's quite a useful kind of mental model to think about how you might respond. If you look in their white paper, they put out 3 different domains. The first one is a service domain. That kind of more meta things like IAM, so access management, also things like billing as well. And then you have the infrastructure domain, so more kind of resource level, a bit more what we're talking about today, your compute, your containers, the stuff running things. And then the application domain. So you'll be running either your own applications or someone else's. They'll have their own application-specific logs and other data too. And obviously, this is a bit of a simplification. Incidents often have all 3 combined into one. It's a useful way of thinking about what kind of parts of an incident you might be responding to. And also in the cloud, we often talk about control plane versus data plane. Again, just kind of getting some definitions out of the way. Control plane, again, more on the kind of access management side of things, more around stopping things. Data plane, the stuff itself, the compute, the data you're dealing with. You're probably very familiar with these terms if you do much cloud. So last year, if you're lucky enough to the DFIR Summit, you will have seen the keynote from Josh and Megan around DFIR in the cloud, all about evidence preservation. In particular, the kind of key takeaway for me would be like, just make sure you enable all the logs, because often in the cloud, they're not going to be enabled in advance. That's a simplification. It's a great presentation. Do go see it on YouTube if you haven't, but that's kind of one of the key things to make sure you do. And they also went through describing a nice kind of hierarchy of logs, all the way from kind of IAM at the top through down to application at the bottom as well. So again, you can see many different ways of kind of splitting these things out, and they all kind of overlap a little bit. And those kind of abuse these things too by adding a couple of extra categories, moving kind of horizontally. Lots of people talk about more undocumented logs or unavailable logs in the cloud. And this was a blog many of you may remember from about 5 years ago. It was quite an interesting one. CEO of a forensics firms, Sherry Davidoff, she had the experience where she found that she was losing some forensic jobs because other larger cloud providers had access to apparently some kind of secret tool or secret access logs, particularly around Office 365. It's quite a tongue-in-cheek blog, but does end kind of seriously too, with some important questions, because it turned out in this case that was actually fairly true. After this, CrowdStrike released a really good free tool to get those logs. Microsoft then turned off some of those logs. So a bit of kind of a back and forth there. But the question she posed at the end of that were, what standards should forensic professionals hold themselves to for disclosure of zero-day artifacts? And obviously, I hope as a community here together, we should also, all agree we should share details about forensic artifacts rather than use them as more of a competitive advantage. What is the responsibility of the cloud providers themselves to either make you aware of these artifacts or make sure they're actually available? And then similar kind of question about order logging preservation. So 5 years ago, a bit kind of prescient. Unless you've been living under a rock, you've probably seen some experiences recently with Azure and Exchange and how some logs were not available unless you're willing to pay for a certain tier. But also full credit to Microsoft, they quickly made these logs available to everyone. So, an improvement there. But obviously, these are questions that lots of people are kind of asking right now. All right, definitions out of the way. Into a couple of examples because they are far more interesting. So I'm going to go through an example attack in the cloud, and then I'm going to also talk about how you might respond to each of these bits. This is a convoluted, not super realistic example in some ways, but I chose some attacks that had interesting artifacts for forensics. And also, these have all happened in the wild, but not necessarily in this kind of combination. So Scott Piper wrote a few years ago about how you could potentially phish in the cloud. So we've all seen how you can do a traditional phishing email, maybe getting people to give you their username and password, or maybe with malicious documents, you open a Word document and gives them access. You can also phish for cloud accounts as well. So the way it works is pretty simple. You send an email saying, hey, I'm the cloud provider. Please deploy this because you have a security issue in your account and this will fix it for me. This does work. So this thing that's going to be deployed, in this case, StackSet, it can deploy something, for example, some infrastructure in your account. So maybe crypto mining. It can also deploy things like roles as well and create trust relationships too. So interesting kind of style attack. In this particular example, they're going to give the attacker permissions to do something with SSM, so Amazon System Manager. There are far kind of more easy ways to do this, but it makes a more interesting example rather than traditional, someone left their access keys on GitHub or someone hacked into a virtual machine somewhere. So basically deploy a role, they can have access to do something. In this case, we've gone with Systems Manager. So in terms of how you might investigate this kind of first stage of attack, if someone has maliciously deployed a role in your account, we can look in CloudTrail. As everyone probably here knows now, free for 90 days, fantastic. Enabled by default, which is great too. Very easy to look up and then query on people creating roles. Equivalent in Azure and GCP. Azure, probably looking at Azure Monitor and the audit logs. GCP, audit logs, system, and admin. Next stage of the attack. Let's say the attacker is going to abuse Amazon System Manager. There was a blog yesterday by Mitiga about how attackers might use this legitimate tool for administrating virtual machines and containers. It's pretty easy. Once you have legitimate access, you can connect to it over the AWS CLI, and you can do whatever you want on these virtual machines. It's just a legitimate way to access virtual machines and containers. The reason I chose this example is because the forensic artifacts are kind of interesting. So if you've enabled them, after you've enabled them, you can have logging in CloudWatch and also S3, showing the commands that
your admins or the attackers have run. And it's decent. We'll show you things like the commands they ran and who did it when. So here we see, I think, who am I and some other example commands. You have to enable this in advance. And most people probably haven't done that. There are also official logs, in a sense, on the instance itself. So let's say we've run this against an EC2 virtual machine. Under var log, which is where you expect to find logs, you'll find some of the commands that have been run, but this is built more for diagnostics and security. So the kind of logging you're going to get there is going to be with that in mind. Interestingly, talking about kind of unavailable or kind of unknown logs, it turns out there are some undocumented logs here. So under the var lib directory, maybe not where you'd be looking, you actually get really great information here. You'll see both the commands that the attacker has run and also the response on the side as well. So you see both sides of that kind of channel there. So maybe they've listed out a document and got the output. You get all of that there. It's available both on Linux and on Windows. In Google, so kind of rough equivalent, I guess, of Systems Manager, you use G-Cloud Compute SSH, so you can connect. And there's less logging here. In general, you can enable the data access log, which I'll show in a second, but generally it hasn't got all that much information. You can enable other things instead to actually record what commands an attacker might have run on those machines via that mechanism, maybe audit D or EDR or something else. Let's skip this one. This is an example of that data log there. As you can see here, maybe can't, it's quite small. There's a user agent that's me when I was running this command. That's pretty much what you get. You kind of get a time and who did it. You don't necessarily get what they did, though, in the case of GCP. Interesting equivalence, though, in Azure. So there's actually pretty good documentation on how the Azure run command works, forensic point of view. And that's because Mandiant responded to some Russian target attacks a couple of years ago. They went through and did all the forensics, and then in their blog said, here's how you find out what happened. And somewhat similarly to SSM, you get pretty good data, both on the commands that were sent, but also the response as well. So you're going to get a channel of both directions if you know where to look. And check out the blog from Mandiant to find out where those would be. So yeah, kind of calling back to that original question at the start of the talk, it'd be great if we as the community did do more to kind of document artifacts in the cloud. There isn't all that much out there right now. So maybe the SANS Slack channel is a good place to start. And finally, I want to show you some kind of final stages of attack. This bit's a bit boring. If you ever responded to instance in the cloud, you will have seen crypto mining so many times. It's always a damn crypto miner. But it happens all the time, right? So at this point, you have access to run commands on the system. We're going to curl or download something from Pastebin, where you can store scripts, and then we're just going to run it. Very, very common. At this point, this looks a bit like more kind of normal host forensics, but some things are still a little bit different in the cloud. So for one thing, I don't know if you're a fan of Chris Hemsworth, in the cloud, it's great that you do have those cloud provider logs because you can trust them, because assume the cloud provider hasn't been hacked, you know, they're going to be legitimate, whereas that's not true of the kind of host level artifacts. Also, I used to do more kind of like on-premise forensics, and it's very rare I'd ever see anti-forensics. I don't know if you guys have maybe seen more of that than I have, but in the cloud, it's really common. You get anti-forensics all the time. Pretty much every crypto mining worm includes some stuff to try and mess with your investigation a bit, which does make it more interesting. But it's not Chris Hemsworth and Black Hat, it's not Shadow Broker, it's not high-end stuff. It's more Homer Simpson. It's just, because the people that write these worms are often not the highest professionals. I'll give you a couple of examples in the anti-forensics we see quite often. This is one that will impact you if you're doing more live forensics, you're listing processes on a compromised machine. Simple shell script, what it's doing is wrapping PS, so list the processes on the instance, and then it uses grep just to hide certain processes. So you won't see anything named, in this case, DDNS or scan. So a very simple way of just hiding processes on the box. I like this one because it's so simple as well. If you use Linux, you'll be pretty familiar that dot means your current directory, dot means the parent directory. I guess technically dot's the parent directory. What these guys do is they stick all their malware in a directory called dot, so then you don't think to look in there. Simple, but I guess it works. Also rename their binaries too. So they're using curl to download files, they rename it CD. and if you change directory, and you're looking through the history on the machine, and it looks like they're changing directory to Google or whatever. So again, pretty common stuff to see. And then finally, just simple kind of timestamp manipulation. So using the touch command of Linux to change their malicious binaries to make it look like they were created there a couple of years ago rather than today, so it doesn't turn up quite so obviously. I'm not sure if you can see it here, but when I was looking at a compromised box, the modified and access times had been successfully changed by attacker, but the created times weren't. I can't quite remember my forensics SANS course a while ago, but I imagine that's to do with the file system. So in terms of how you might actually get these files, so I'm trying to convince you why sometimes you need to get the files and the resources as well as the logs in the cloud. A couple of kind of standard ways to get all the files in the cloud. In the previous talk, we heard about some of this too. You can get a disk image in AWS, kind of standard way that you do it on premise in the sense that you'll be using a tool like DD to create a disk image. But the way you normally start by doing that is you get the volume or disk on the virtual machine. You then make a snapshot, turn it back into another volume, so you're not impacting the original system. And then you can then DD it off and then upload and store it in cloud storage, S3, something like that. A couple of caveats here, though, if you are doing that. It's surprisingly slow for large disks. It looks like everything's going great, and it suddenly gets really, really slow. It's because there's this thing around how the way that snapshots are restored in AWS into a volume, block by block. It takes time unless you enable fast snapshot restore, costs like $1 or $2, so not that expensive per snapshot, but it also doesn't work instantaneously either. But basically, it can take you a while. Credit to AWS, though, they have open source a tool to help you do this, so that's great. It'd be nice if it was just an easy download kind of link, but I think they've got their own reasons for not making that available. And also, if you're doing this with system deployed from the marketplace, you have to get around some copyright protection, which is fine in this case, but you have to turn off instances and or the when you attach them and some other stuff you need to do. There's also an API which gives you some kind of access here. You see reference at the bottom, and also you can do some things where you kind of do this in parallel as well. So there's a bunch of stuff you can do to make this faster, but it works. There are also some other options too. So you can use SSMs, the agent I spoke about a minute ago, to collect files of the system live. Pros and cons of kind of pulling files live. There's a great presentation on how to do that. It means you can do it very quickly, avoid doing a full disk. You have EDRs installed, potentially this too. And GuardDuty can now also scan, so AWS's own detection technology can also scan disks as well. There's a very good job of detecting things. It won't give you all those files, but at least detect malware pretty effectively. In Azure, there's a really nice, easy download link, which is great. But the network's quite flaky. So if you've tried this, you'll find that often those downloads will fail. The trick there is pretty simple. You need to wrap it in a bunch of retries, eventually download works. Certain regions are more flaky. Also, we've seen certain times have been more flaky as well. But wrap it in a retry rather than using the UI and it'll work. Google works pretty well, actually. You just create an image from the disk really easily, choose the format options, so VMDK or something else, sticks it in cloud storage, and then you download it. So pretty easy to do if you're using Google Cloud. Second example, and then we're all home dry. I managed to stick in 3 buzzwords here: cloud, Kubernetes, ransomware. And this follows on quite nicely from the previous talk by Jonathan Polling. So this is not going to go into detailed EKS forensics because that was the last talk. But just to try and make things a bit more interesting, I picked on EKS because it's quite complicated. It demonstrates lots of different types of logs. So let's say in the second attack, you're running some kind of web application in a container in Elastic Kubernetes server. So one way of running containers in AWS, and someone's used Log4Shell, so pretty notable vulnerability from last year, to pull down and yet again run a malicious script. The way this works, you can see there is they've stuck on the user agent, base64 encoded, download and run this. So pretty common attack. Next step, classic way of kind of escalating privileges or moving laterally in any cloud environment, all the cloud providers, is to hit some kind of metadata service. There's a magic IP address you can hit. It'll tell you things like what region is this container or instance running in. It'll also potentially give you some short-term access keys as well. So if you've got some kind of role associated or profile associated with this, you can then move using that. We've seen a group called Team TNT do this a lot. This script is one that they use quite often. It's hitting, you see the IP address, the container metadata service, and then gives them an access token to move around. So yeah, I'm not going to go through all this, but there's many different types of logs, both at the cloud level, container level, and at the node level too. You can potentially be pulling also files as well. So on the cloud level, stored in S3, you have numerous different things there if you've enabled them. As said in previous talk, tell you around things being started and stopped, containers being started and stopped. If you're running Kubernetes on EC2, so on the virtual machine, as opposed to managed service like Fargate, we also get some Kubernetes and Docker logs as well on that instance. Again, see the previous talk. And then there's inside the container itself too. And sometimes you get the same type of data, but presented in different ways. So you can pull memory either node or container level. Now node level is the recommended way of doing it. You can also pull all kinds of things too. You'll get different versions of files as well. On the node itself, because it's a version file system, the default Docker file system, you might get multiple versions of the same file too. So the point of this really is that lots of different files you can get. Some are logs, some are artifacts. If you hit an instance, go and take a look and see what's best to grab. Kind of ran through most of this, but yeah, you can pull memory inside containers, you can pull outside them, you can pull files from containers if you have access enabled in advance. You also speed up how you grab data too. If you have to do it, you can kind of hit the Kubernetes API yourself, and there's some faster ways of doing that too. But generally, you don't need to be that fast unless you're worried the container is about to turn off. So yeah, if you want to hear more of this, go back in time an hour, hear the last talk, or if you're watching this on YouTube later on, then look this talk up on YouTube. So final step of the attack. So we've got access, we've got credentials. Something that I've seen a lot of people talk about recently is ransomware in S3. So SANS have done a bunch of talks about this recently. AWS themselves published some white papers on this too, which is great. You typically notice this has happened because, hence the Pulp Fiction meme, all your files are gone in the bucket. At that point, you have to work out what to do next. And yeah, as I said, Amazon have written a great blog on this, and they talk about common access vector here is stolen access keys, GitHub, etc. Although less common these days, thankfully, or someone stealing from a metadata service, a bit different but related to what I showed you a second ago. The key question that you really care about if this happens to you though, is this extortion? Is it proper ransom in a sense? Have they stolen your files and then they're going to go and email some journalists, or unless you pay them some money, they're going to give all your files away? Or do they just delete all your files? In which case it sucks, but it could be worse, right? I mean, hopefully you have backups and restore and you'll be okay. And there's a few different log sources here. This is all on the cloud provider level. If you've enabled them, there's some pretty detailed stuff on CloudWatch and S3. Most people haven't enabled them. Those logs get pretty big. But for billing purposes, you can see just egress traffic, so traffic leaving your AWS estate to other regions. So if they've downloaded those files to outside of AWS or outside that specific region, you're able to kind of work it out that way. There's a few other things you can do too. And then there's some stuff in CloudTrail too, potentially. In terms of the response here, a few different things you can do. Well, not so much after this has happened, but more like, before. Obviously, you can do things like object lock in S3 to make it harder to delete your files. You can do versioning, you can do backups. GuardDuty now has some decent detections too. Or, well, it will tell you, you've been ransomed, but when you go to the empty bucket, you kind of know anyway. And then finally, if they have stolen credentials to do this, you then have to deal with that too. And there's some great playbooks out there on how to do that. Okay, almost finished now. So kind of rounding up. Hopefully I convince you logs aren't always enough, but sometimes they are. So do look at the resources as well. Do make sure your logs are turned on, because at least half of them aren't going to be turned on by default. And then do make sure you can access resources as well. You actually get access to those resources, because again, unless you set up in advance, often you can't. So some resources for enabling those cloud logs. Jonathan Polling, previous speaker, he did a 150 slide presentation at RSA, going through every log site, every cloud provider. So great reference to kind of run through that. There's also Prowler, so a free open source tool that automates some of these checks for you. There's also a spreadsheet from a public spreadsheet, and there's a few resources. Also, of course, SANS 509 goes through this as well. In terms of making sure you can access resource level data, is somewhat similar, where again, you need to check some things in advance. So for example, if you're running ECS, so another way of running containers in Amazon, Make sure potentially you can do ESIS exec, which gives you permission to access those containers if you're happy with that from a security point of view. Because if you haven't enabled that access in advance of creating the container, you can't enable it later on. To kind of check and review what access you want to have. As always, there are some trade-offs here though. Practice and test in advance. People go through and remove permissions to grab this data as well. That happens a lot. So it's no good just to do a one-off and check you have access. You have to every now and then do a check and make sure you can actually get kind of your forensic data. Forward logs to CloudWatch, SIEM, EDR can help. Do some SANS courses, yeah. And yeah, the new SANS course will be interesting to see as well, talking about Linux forensics. And then finally, thank you. I found Datadog's resources around like a encyclopedia of previous cloud attacks quite useful. Go through some examples. So yeah, a good resource to check out there. And yeah, exactly 10 minutes left. So it's perfect timing with the drop. Good. If there are any questions, I'd be happy to answer them.
Any questions from folks here? All right, I didn't see any in Slack, but if there are any that happen to pop up, we can answer those in the thread. Thank you very much, Chris.
Oh, wait.
Oh, we do have one. I'm sorry. Oh, my bad.
You talked about the cost of the logs, and that's something we've heard pushback from customers. If I enable flow logs, for example, I'm going to get thrashed. How do you balance the needs of security versus the needs of the accountants?
Yeah, I guess that would be to the questions like how do you balance the need of security versus the accountants? I do a lot of both. It would depend obviously a lot on the business. So I see like finance, insurance, they often go for everything, just full everything. Whereas, some other industries, particularly kind of mid-sized businesses, can't afford to do that. So it depends on, a lot on your environment, but also you may have different accounts as well. So do you need the same level of logging in every account? Because you can obviously enable crown jewels in one account, which may be more locked down as well. And there's other ways you can save money too. I mean, not every logging resource is created equally. So some of these ones are very noisy, like S3 access logging. Hence why often that's not turned on. Some of these, like the SSM logging, it's not very noisy at all, so it's pretty cheap to enable. And then there's some smart ways too of reducing the log size too. So I haven't used it myself, maybe some of you have, but there's the algorithm that will like chop down the size of logs automatically about 90% by kind of decompressing them but in a human readable format. Can't remember the name, I think it was the Salesforce guys came out with it. There's also ways you can, cut your SIEM costs, I guess, as well.
Okay.
All right,
Thank you
run
so
off the
much.
stage.
Thank you. Great job.